good morning. I'm Sheikh Bhaskar from the Department of Mechanical Engineering. Today my topic is heat conduction equation in spherical coordinate system. Why spherical coordinate system is used? Spherical spheric, spherical coordinate are ideal for problems with radial symmetry. Heat flow in space depends mainly on radius. Angular variation may also exist in some cases. Using Cartesian coordinates complicates the equation unnecessarily. Spherical coordinates reduce the number of spatial variables. They improve physical interpretation of heat flow. Common applications include parliamentary heat transfer. Nuclear fuel elements also use spherical models. Thermal analysis of pressure vessels uses this system. Hence, spherical coordinates are essential in heat conduction studies. Definition of spherical coordinates. In spherical coordinates, a point is defined by radius, polar angle, and azimuth azimuthal angle. The radial coordinate is denoted by r. The polar angles theta is measured from the positive z-axis. The azimuthal angle is measured in the y-axis, y to x to y plane. These coordinates replace x, y, and z unit vectors. Change direction with position differential length elements differ from certain coordinates area and volume elements are more complex. Geometry strongly affects heat flow formulation. Proper understanding of coordinates is circular. Azimuth Assumptions in heat conduction analysis. Several assumptions are made for driving heat conduction equation. The material is assumed to be homogeneous. Thermal conductivity is considering constant. Heat transfer occurs only by conduction. Internal heat generation may or may not be presented. The medium is isotropic in thermal properties. Temperature is a continuous functions of space and Radiation and convection effects are neglected. This system flows Fourier's law of conduction energy conversion applies locally. This assumption, especially the mathematical formalization. Now moving to general heat conduction equation. The general heat conduction equation is derived from energy balance. It is accounts from conduction, storage, and generation of heat. In three dimension, it includes spatial derivatives in direction. The equation can be steady or unsteady. Heat generation may be included as a source term. The equation from depends on coordinate system. In spiral coordinate terms involve r, theta, and psi. The lam the Laplacian operator changes accordingly. This equation governs temperature distribution. Understanding it from its essential for solving problems. La, Laplacian operator in coordinates. The Laplacian operator represents spatial variation of temperature. In the spherical coordinate, it is more complex than Cartesian. From it includes radial and angular derivatives. The radial term consists r square in the denominator. Angular terms involve involve sin functions. These terms account for geometry effects. The operator reflects how heat heat spreads in space. Symmetry simplifies the Laplacian significantly for purely radial problems. Angular terms vanish. The operator is central to condition equation. Correct formulation is circular for accuracy. Now moving to general heat conduction equation, spherical coordinates. The heat conduction in spherical coordinates includes time depends depends. It consists of radial, polar, and absolute terms. Each term represent heat definition in the direction. Internal heat generation may be include the equation valid for transit conduction. Thermal differently appears in the equation. This form is used for general spherical problem. Mathematical complexity is higher than Cartesian Cartesian from. However, it accurately models spherical heat flow, boundary, and install condition. Complete the formulation. Steady and now moving to steady state heat conduction equation. In steady state conduction, temperature does not change with time. The time derivative terms becomes zero. This simplifies the heat conduction equation. The equation reduced to septic spatial differential equation. Heat generation may still be presented. Without heat generation, the equation becomes spellifer. Steady state analysis is common in insulation problems. It helps determine temperature distribution. Many engineering designs use steady state solving solutions, and analytical solutions are often possible in these cases. Moving to one dimensional radial heat conduction. Many spherical problems involves only radial heat flow. Temperature varies only with radius or angular derivatives become zero. This reduces the equation to be dimension. The resulting equation is simplified and solvable. It is commonly used for the solid spheres. Hollow spheres are also analyzed using this form. Heat transfer in spherical shells flows. This equation boundary condition are applied at inner and outer surfaces. This simplifications is widely used in practice. Heat conduction with internal heat generation. Some materials generated heat internally. Example including nuclear fuel planets. The and chemical reactors. Internal heat generation add a sources with source term to the equation. These terms depends on generation rate. The equation balances generation and conduction. Temperature temperature profiles become non-linear. Higher temperature occurs at the center. Proper in modeling is important for safety. This form is used thermal stress analysis. Analytical or numerical solutions may be heat generation significantly affects temperature distribution. Boundary condition in spherical system. Boundary conditions are essential for solving conditions equation. Common boundary conditions include specified temperature, heat flux. Boundary conditions are also used. Convention boundary conditions applied at the surface. Radiation as may include as in approximate inner and outer surfaces require separate conditions. Symmetric conditions simplify solutions. Boundary conditions represent physical constant. They influence boundary solutions behavior strongly. Incorrect boundary conditions lead to wrong results. Proper selection is critical and analysis. Conclusion: heat conduction is spherical coordinates has wide application. It is it is used in nuclear engineering and aerospace system. Thermal and analysis of planets uses the model insulation designs of thermal tanks relies on it. Heat transfer in biological tissues is also analyzed. The spherical coordinate system simplifies symmetric model problems. It provides physically meaningful solution. Understanding the governing equation is simple. This equation from the basis from the advanced simulation. Mastering of the topic is important for the thermal engineering. Thank you.